So in today's lesson, we're going to carry on our conversation about transformations of quadratic functions. You'll recall that yesterday we talked about reflections and stretches and compressions. And today, hopefully after our short investigation, you are now able to sort of think more deeply about the effect of changing this value h and also this value k here on the position of your parabola. So in our investigation, hopefully what you saw was as you changed the values of h and k, you saw the graph move either side to side or up and down. So the process of moving a graph side to side or up and down is what we call a translation. So we're translating that original function to a different position, either vertically or horizontally on our grid. So I want to first start by talking about what we would call a vertical translation. And so a vertical translation is when you're moving the graph up and down relative to its original position. Okay, and so we would say, if we're looking at, and let me write this out for a second, I think we should have this as a reference. If I have an equation in the form y equals x minus h squared plus k, then the vertical translation occurs as soon as we change the value of k here. So look carefully at where that value that's being added or subtracted from your x value, whether it's inside the bracket or outside the bracket. So for instance, if I see, for instance, that a value outside any brackets that doesn't have the square applied to it, then I know that I have a vertical translation. And that means that the graph is going to move k units up. All right, so for instance, if I gave you the graph, if I said to you, well, graph the function y equals x squared plus 5, I'm noticing right away that this plus 5 here is outside any brackets with my square applied to it, right? And so that's telling me that I am going to be moving, the position of my vertex is going to be 5 units up from 0. So, and in fact, my vertex at this point would be at 0 and 5 because I'm not shifting left or right. And so I go ahead and I locate my vertex. So my vertex would be normally at 0, but it's not going to be in this case because I'm shifting my graph 5 units up. And so at this point, because I've not stretched or compressed my graph, I can use my 1, 3, 5 method to graph 1, 3, 5, except that instead of starting at 0, 0, I'm starting at 0, 5. So I would go over 1, up 1. Over 1, up 1 on the other side if I want to right away. So over 1, up 1, and then over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. And then I do a mirror of that on the other side. And that's it. And I'm going to be drawing more graphs on here, and so I'm going to label this as y equals x squared plus 5. And so what I'd like you to do next is I'd like you to go ahead and graph the following function, which is y equals x squared minus 3. Go ahead and do that, and when you're ready, go ahead and resume the video to ensure that you've done it properly. All right, I'm ready to take this up. So when I look at the graph of this function, I'm noticing that this minus 3 here is outside the brackets. I'm going to kind of revisit that. Right over up here, there's no value beside my x inside any brackets. So that tells me that this motion is a vertical translation, and it's a vertical translation by 3 units down. And so I can tell right away that my vertex is going to be at 0 and negative 3. In other words, what was at 0, 0 is now going to be 3 units down. And so at this point, I'm ready to go ahead and locate my vertex. My new vertex is going to be down here at 0, -3. And I'm still going to apply my 1, 3, 5 graphing method because there isn't a stretch or a translation indicated over here. So over 1, up 1, over 1, up 1, 2, 3, and oopsies, and then over 1 and up 1, 2, 3, 4, 5. Let me see if I got that right. It looks good. And then I just mirror that on the other side of my axis of symmetry. And I'm good to go. And that's y equals x squared minus 3. And again, my new vertex is where I expected it to be. And the next thing that I want to talk about is the horizontal translation. So now we're looking at moving our graph left and right instead of up and down. And so I'm hoping, I'm going to just write out our reference equation, our equation in the form y equals x minus h squared plus k. So in this case, when we're looking to describe the horizontal movement, whether left or right, we're looking at the value of h here, okay? So you hopefully noticed that the value of h and not the sign of h tells you that you're moving the graph to the right. So for instance, if I were to have the equation y equals x minus 1 squared, and then I look at the value that's inside that bracket, ignoring the 1, or the negative rather, and that tells me that I'm moving, this graph should be located 1 unit to the right. Okay, so let's take a look at some examples here. So another thing to note is, I noticed that in this equation here, y equals x minus 10 all squared, I noticed that the negative 10 here is inside the bracket and has that square applied to it. And so that's what's telling me that this is a horizontal translation, moving side to side, as opposed to a vertical translation, moving up or down. Right? And so I will also remember that the formula is x minus h. So the value of h in this case is actually 10, which tells me that I'm moving and centering my graph, starting it at my vertex at 10 and 0. And I'm going to start from there. So this is going to be a little bit kind of squished. Right, I'm going to start at 0, and I'm going to plot, or 10 rather, to the right, and I'm going to apply my 1, 3, 5 method. So over 1, up 1, over 1, up 3. I can kind of get the corner of this, but I'm actually just going to do it on the other side. Over 1, up 1, 2, 3, and over 1, up 1, 2, 3, 4, 5. So, I don't really have the space. I'm going to draw in what I can here. And there's my graph of y equals x minus 10. I'm running out of space here, people. And there's a little squared at the top here. Let me see if I can move this over a bit. No, I can't. Not without shifting everything. So there, I'm going to try to put this little squared over here. Well, you can just imagine that it's there, or you can write it in for yourself, the square outside the bracket. All right, so now what I'd like you to do is I'd like to go ahead and attempt to graph this guy right over here, y equals bracket x plus 7 all squared. And when you're ready, resume the video and we will take it up. All right, so when I look at this, I can see that I have a 7 inside the bracket, but I need to be careful here because, my regular equation, just the standard form of this function, is y equals x minus h all squared, right? And so if it's a positive 7 that I have in there, that's kind of like I have x minus negative 7 to give me that positive 7 that I end up with. So the negative 7 actually means that I am going to be moving my graph 7 units to the left. And so when I go ahead and I plot my graph, I'm going to start that 7 units to the left and then go from there. So over 1 up 1, over 1 up 1, over 1 up 1, 2, 3, and so on and so forth with my 5. But notice that I have a new axis of symmetry with my horizontal translations. It no longer goes through the y-axis. So there I go, y equals x plus 7 squared, and I'm done. All right, so I would like for you to try example number 2 on your whiteboard, and then we'll take it up. It says it's a lot like yesterday's example. Without sketching each parabola, I want you to state the direction of opening, the coordinate of the vertex, the equation of the axis of symmetry, the domain and range, and the maximum or minimum value. Go ahead and try these, and then we will take them up together. Maybe you want to do A first, then pause the video, try it, resume, and watch my solution to A, and then maybe give B a try, and then watch the solution to make sure you're on the right track. Okay, so when I do questions like this, I first kind of have to visualize it. And so I'm remembering that the general form of these equations is y equals x minus h all squared plus k. And so when I look at this equation, I'm looking to see, well, if it's a translation, is it a vertical or is it a horizontal translation? And in this case, the plus 4 is outside the bracket. So really I'm looking at 4 being k in this situation. And k indicates that this is a vertical translation. And so a vertical translation 4 units up. So I create a little sketch for myself of this. So I'm going to do that. Let me see. I'm going to try to do that right here. Oops. Just to kind of visualize what's going on. And that will help me sort of figure out some of the other aspects of this question. So I'm envisioning that this parabola is going to have its vertex at 0 and 4, just 4 units up. I also know that when I look at the sign of my x here, the x is actually positive, and so you'll remember hopefully from yesterday that that means that my parabola is opening upward. So really I just have a parabola that is essentially y equals x squared, but just 4 units up. So let's start to answer some of these questions. So direction of opening, so I can say that it opens upward. Right? I can tell that my vertex is only just 4 units up, so it's still at 0, but it's 4 units up. The equation of my axis of symmetry, well, my axis of symmetry, you'll remember, just goes through my y-axis through x equals 0. So my axis of symmetry is at x equals 0 still, because I haven't shifted it left or right. And then the domain and the range. So my domain, I can see that my domain in terms of my x values, this graph over here is going to keep going and going. So, and it started at 0 and it's going to go in to each extreme. So I know that my domain is x is such that x belongs to the set of real numbers. And my range, however, is a little bit different. I can tell that my y values cannot go below y equals 4. So I'm going to say, well, y belongs to the set of real numbers, but y has to be, in this case, greater than or equal to 4. And I'm done. And the last thing is, well, what is do I have a maximum or a minimum value? Here I have a minimum value because my graph ends at y equals 4. So I have a minimum at y equals 4. And I'm done. So hopefully you did okay with that. Let's take a look at the next equation, next example. So if you haven't tried it yet, pause the video and give it a try first. So when I look at this equation, I'm seeing that I have this 4 that's inside the bracket. So x minus h, I have x minus 4. So that tells me that my h value, is 4, which means that I've moved my graph 4 units to the right. So if I were sketching this, and I find the sketching is important, just to help me visualize, that all I've done is I've gone ahead at 4 over here. Let's envision that this is at x equals 4, and I've just shifted this graph to the right by 4 units. And so examining my, I can also see that the sign over here is still positive. I haven't added a negative there. And so given that, it's still going to open upward. I know that my vertex is now, instead of at 0, 0, it's at 4 and 0. My axis of symmetry is no longer at x equals 0, okay? It's at, here it is, that's my mirror line, it's at x equals 4. Okay, and so my domain, my x values can be anything, so x is such that x belongs to the set of real numbers. And my range, this is telling me that still y can't go below 0. So my y belongs to the set of real numbers, but y has to still be greater than or equal to 0. And then finally, do I have a minimum or a maximum here? Well, I have a minimum because my graph is opening upward. And where is that minimum? My minimum is at y equals 0. So that's it. I'm going to be assigning you some homework, so make sure you check out Google Classroom to ensure that you are practicing some of these skills. And tomorrow we're going to be combining translations, reflections, and stretches and compressions. So make sure you practice these individual skills so that you're ready to put them all together in tomorrow's lesson.